In order to quantify compounds, we need to ask the question, what is in a mole of compound? Remember that the chemical formula tells us the number of atoms in a molecule of a covalent compound, or the number of ions in one formula unit of an ionic compound. It also tells us the number of moles of each element. A simple chemical formula, along with the molar masses of the elements from the periodic table, will allow us to quantify a compound by moles, by mass, or by number of atoms or ions. We can find the moles of each element of a compound in the chemical formula. Using ethanol as an example, we can quantify carbon, hydrogen, oxygen, or the compound as a whole. CPD is our abbreviation for compound. The chemical formula tells us that there are 2 moles of carbon, 6 moles of hydrogen, and 1 mole of oxygen in 1 mole of compound. The molar masses of the elements are found on the periodic table. The molar mass of carbon is 12.01, so the mass of carbon in ethanol is 2 times that amount, or 24.02 grams. It is 2 times that amount because there are 2 moles of carbon in a mole of ethanol. The mass of hydrogen is 6 times the molar mass from the periodic table, or 6.048 grams. The mass of oxygen is 1 times the molar mass from the periodic table, or 16.00 grams. If we add these 3 masses up, we find the molar mass of ethanol, which is 46.07 grams per 1 mole. We can find the number of individual atoms of each element, knowing Avogadro's number and the number of moles. Avogadro's number, which is given the symbol N sub A, is 6.02 times 10 to the 23rd power. There are 2 times Avogadro's number of carbon atoms, 6 times Avogadro's number of hydrogen atoms, and 1 times Avogadro's number of oxygen atoms. Notice that the constants in front of Avogadro's number are the same as in the mole column and the mass column and come from the subscripts in the chemical formula. The atoms add up to Avogadro's number of molecules in the compound. It is also Avogadro's number of formula units, but since this is a covalent compound, we can use the term molecule. In summary, we have seen that the chemical formula tells us how many moles of each element are in a mole of compound. Combining this with the molar mass of an element from the periodic table, we can find the mass of each element in a mole of compound. Multiplying the moles times Avogadro's number, we can find the number of individual atoms or ions of each element in a mole of compound.